Hello and welcome to the scary episode, the scary tutorial video 13. Unlucky for some. So, what I'm showing you now is my prepare code. Oh, with a baby panda. So behind the scenes, I just make everything into a baby. So we've got a baby panda. More importantly, also we've got a creeper with a little bit of coloration on. I'm just experimenting with possibly looking at some lighting. Anyway, the most important thing is down the bottom, inventory. So this episode is about inventory. Um, so down the bottom now, I can press R, and you can see the little black square or box highlighting different textures or different minerals, block types. So if I select soil now and then do some building, the building system, now we can build on the side of blocks, perpendicular like that, or indeed underneath blocks, on top of blocks, depending on where we're pointing our mouse. So now I've got soil, but if I wanted some ice, oh, that's very scary of the creeper, isn't it? We can get to ice, and if I keep pressing R, it just cycles round. So using some modular arithmetic or some basic logic as well to achieve that, which we'll get into. Yep, we can select the grass block, and so forth. Lovely. Also, you might have noticed the terrain looks a bit different to our current state of terrain. So I've added some small and easy improvements for our terrain, which is probably my favourite thing in developing this in these tutorials, is coming up with ideas for biomes and the way the world looks. I think my favourite thing to do with like Minecraft or Minecraft-like games is just creating a world and then going on explorations of that world. Um, it's particularly exciting to try to find areas that are like beautiful and interesting and strange, and then to try to engineer those, but without prescribing them. Um, oh, which reminds me, there's a wonderful YouTuber, or really, he works for Mojang. I've forgotten his name, but I'll put a link in the description. He just a few days ago, and it's February 2022. You probably are listening to this, watching this tutorial in the future. Anyway, relative to my present, released a few days ago, and he's talking about very similar techniques to what we've applied in terms of Perlin noise and biomes and things like that, and it's given me some ideas as well. So I'll put a link in the description to that video. Right, but to get started, we need to do some like housekeeping, some little improvements, including to the Perlin terrain. So I've put some notes down because of the little jobs. Right, firstly, linear fog. A couple of videos ago, hopefully last video, but it was probably the video before, I mentioned at the very end that I think I remembered you could do linear fog in Ursina, and you can. So I'm on the cheat sheet website. You can just go to ursinaengine.org, put together by Petter Amland, which is really well documented, which is why I think Ursina will be very popular, because of the strength of its documentation online. I hope these videos are contributing to that. So looking at is it the entity? No, at the scene class object. At the bottom here, I noticed that you can set the fog's density to either an exponential density, that was a word that I couldn't remember last time, which is a default, or linear density, start and end. And in developing with Unity, I remember, and I was developing for VR, so we had to optimize things, and linear fog we found to be much more efficient. So I'm going to set mine as linear. So the first item in the tuple here is where the fog will begin, and the second item is where it'll end. So let's go and give ourselves some fog. So I need to open up our main module. Make sure I'm in the right place. Yep. So if you haven't watched any of these videos, I don't know, welcome to episode 13. Obviously, I recommend going back and watching them in order so you know what's going on. But if you haven't, the main module sets up our application, gets things running. And I was going to, oh yes, and all of these different modules, which are just Python files, so text files where we put our code and we put code that does different jobs into different modules. Like the inventory will have its own module, the mob system will have its own module, and it's just a different Python file which we connect together with these imports at the top. So in here, in our main module, and this is the main module is where you run the application. So here we go, line 28 in the current version of the code. Scene fog density is an exponential number, an exponential value. So let's start it at 3 meters away, or no meters away from our player, to about 100 meters away, and let's see what we get. Yes. I'll just have a look at the next job, which will be, the config file. So probably for about 4, and our panda is the original size. And I haven't got terrain generation automatically on, so I'll switch that on with G to toggle that on, so that we can have a look at the fog. Yes, so we can see some fog, which I'm using it really to give a sense of distance. Things look further away if they have that fog effect. There we go. Right, and so if you wanted to play with that setting, maybe if you wanted it thinner, then you kind of like stretch the fog out, so it only begins 200 units away. So let's try, perhaps I'm wrong, let's try 50, so it should be thicker because it's like smushed into a denser range, or a smaller range, therefore the fog itself is denser. I should keep the colour the same. But next, I kind of like playing around with a white colour. At the moment, we're matching the fog colour to the sky colour. So yes, indeed, it's gone thicker there. So that's nicer. And of course, we can run now by holding down Shift and forward. We've got a little bit of field of view effect. There we go. So things in the distance are completely, what would the word be, covered covered with the colour of the sky, which kind of makes sense in tying together all the atmosphere. Right, so I think that's a bit too thick, so 100, okay, let's negotiate, 75 units. And now let's just have a look at, in fact, I'll comment that out. I just wanted to make the colour of the fog white. I think that looks pretty good as well. Again, it will reflect different different aesthetics, or not really aesthetics, different purposes or functions for the fog. I really want to use fog in order to give a greater sense of distance and kind of depth to the aesthetics, the look of the world, which I think is achieved this way. Yeah, and white looks pretty good for that. But then again, oh, panda just dropped from the sky. What I'm planning on doing is building a game or games that will have different, like, I was going to say planets. I'll say planets, different planets, and then you can have different fogs, or indeed in a Minecraft kind of thing, different biomes could have different fog colours, atmosphere colours. And when we come to look at weather and nighttime, daytime cycles and things, which I don't know when that'll happen, maybe the next video, maybe a couple of videos time, depending on where we get with the inventory and things. We could use the fog because the lighting is difficult to get working in terms of how we're using texture atlases, and particularly for me because I like to develop on a Mac. So at the moment, Ursina is not compatible. Well, its lighting shaders aren't easily compatible. it makes sense to try to create our own lighting via coloration or colorizing, like I did with the mob's texture, the creepers texture you saw at the start of the video, plus some other effects like using fog to, we could use like a black fog and make it a lot thicker for nighttime, as well as turning off the sky or making the sky go black. Okay, so we've done linear fog. Let's tick that here. Right, config file. What on earth am I talking about then? So in the last probably 3 videos, I keep referring to less right. Let's just go and have a look on on my issues page. Maybe I've closed these issues, have I? Yeah, 8 closed. Sorry, I'm not in the best place for my Wi-Fi, so it's a little slow. Oh man, so this was like a month ago. No, that wasn't the one. Maybe it's still up here. Oh, there's less right. Right. I hate that when something's on the screen, so people watching this can see what I'm looking for, and for some reason, I don't know if other people recording YouTube videos or doing presentations have the same problem, but when you're explaining to someone, trying to look for something, something goes wrong in your head, and you're kind of blinded to things. Anyway, the point of this is, as Les Wright has explained, look, he's kindly given examples and clear instructions of how to sort things out, which is absolutely fantastic. By the way, you don't have to go into this detail. If you want to, if you go to the my GitHub repository, you can go to the issues page or the issues tab and then request something, a feature of the game or an improvement, etc. Of course, I love it if you go into depth and give me screenshots and things. It's really helpful. But basically, we're just going to write a file where we store 1, 2, 3, 4, 5, 6, these 6 directions as vector 3s or tuples. And then in our code, we can replace these 6 with a reference to these guys, which Les Wright has done down here. So look at that. The code has squashed from that into that. And it's faster because we're only creating these guys once at the start of the application and then referring back to them. Whereas this, when we're doing like blister mining, we're creating all 6 of these every time we want to mine a block, which makes no sense. So what we want to do is create a config file where we can store this and other things. Actually, when we do the inventory, it will make sense to start storing our block type data in a prepared data structure, in a dictionary or something. Right, so let's go and do that. Okay, so I'm back in I'm back in Code World, and we can now make a new file. There we go, and we'll call this, as is tradition, config, or you can call it. People call it CFG, don't they, as well? We'll call it config .py, and I want to save. Select language. Oh. I was writing config in the search for language box, input fields, that's the word I'm looking for, input field. So now we can save this, save as. So I'm in my project folder where we've got everything, including my prepared code, sorry. I should come up with a better system where I keep this off the repository. Although, if you go into the repository, download the repository, you can, or the folder in this repository, you can have a sneak peek look at what I'm preparing for upcoming videos and things with these prep versions. Anyway, what are we calling this? Config.py. Save. Right, let's just explain what we're doing in this file. Our configurations file where we set up where we set up, actually I want those, a separate word, where we set up, because it's a verb, set up default values as well as handy lists and dictionaries for efficiency. It's a very official, formal way of starting. Okay, so usually a default list or whatever will be written with capitals, so you know that it's a config or belongs to some configuration. But less right, he doesn't like that. So in honor of less right, and I'm a fan of doing things in your own way, as long as you're clear about it and you communicate to everyone what your logic is, then that's fine. So everyone, so no one's confused with what you're doing. Although, if you're just programming on your own, do what you want. If you're part of a team or kind of skilling yourself up for becoming part of a development team, then at least know of the conventions and maybe try them out. Anyway, we'll call this 6 cube ders. There we go, 6 cube ders. We don't want our variable name too long, but we do want it to be clear so we know what it is. Right, what are we talking about? We have two places to improve, two modules to improve where this is used. So this is used in, I've got to avoid my prepared code, in mesh terrain, certainly, and then in maybe the mining system or where we're spawning walls. So we're in mesh terrain. Ah, there we go. Oh, that was easily found. So yeah, when we're generating the walls, so when we're mining and we're spawning further layers down, we are creating all of these vector3 objects. So let's copy those, go back to our config file, and just drop them in there. That's nice. I might just put that square bracket there, so I'm very happy. Now, vector3 doesn't exist here, and less right did things differently. He used a tuple, which you can use, I think in Ursina, you can just use tuples instead of the vec3, but then you'd have to be consistent, else things would break. And I did break things actually when I was implementing this myself a week ago or so, or 2 weeks. So let's just build with vector3s at the moment, and we could refactor that later or experiment with that later. So we need to say from Ursina import vector3. So we're importing that class, that object, so that our code can deal with it, can recognize it. There we go. So we've copied and pasted these in the same order. So what these are directions or trajectories in 3D space, which we dealt a lot with in the last video, although I did that very slowly. If you haven't watched the last video, that was where we were coding the building system, or developing the building system, so we could build perpendicular blocks on the side and the top and the underside of other blocks. And I was moving very slowly. I was a little tired. Anyway, these vector3 objects are directions in 3D space. So it's x, y, and z for each of these components. So y +1 means up, -1 is down on the y-axis. Now we're on the x-axis, so that's left, that's right, and then finally the z-axis, back and forward, or forward and back, depending on which way Ursina points things. Okay, so I'm going to use the same order. So now let's see if we can use this in mesh terrain. Well, the first thing that we're going to need to do is import that. I might import it here in the function itself. So from config, and our file, our mesh terrain file module, will be able to find the config file as long as that config file is inside our project folder, which is easy to remember because we're putting everything we make to do with this project inside that main project folder. import, what's it called? 6 cubeders. There we go. So now I can delete this. And I can say plus, so WP doesn't exist anymore, but I can just say my 6 cube directions, which is exactly the same thing. Look, they're exactly the same order, although the order doesn't really matter here, I guess, because we just the key thing is we cycle through all of them. Where are we? Mesh terrain. Lovely. There we go. And epi is just, in this case, we're mining, so it's like where we've mined, and now we're looking at all these 6 directions and seeing, do we need to spawn a wall there? Anyway, that's explained in the video where we coded this many videos back. So done. Oh, and look, when we generate a block, we're always generating soil down there, or asking for soil. I just noticed that because upcoming things to do, especially with the inventory, is to be able to build whatever block type that we want, whatever mineral we want. So that one's done. We've used 6 cubeders there. Let's just go and run the code to check that things are working okay. So when you're operating on vector objects, adding them together and things, you might make a mistake, or things might not be compatible. So if I right click, I'm building, I meant to left click, there we go. If I left click, everything's still working. We are spawning walls, and we've got the illusion of digging down to the center of the earth. Oh, let's blister mine. Hold shift and you can blister mine. Oh yeah, one thing that we're going to get to, that's on my list, is you see where we bump our head here and kind of get stuck. I'm going to sort that out. So we've got some collision improvements, some bugs to figure out. Okay, so next thing, so we've got this, and we use these 6 directions in one more place, don't we? So that's probably in, well, let's have a look through mesh terrain, just in case I've used it again anywhere. Nope. So I think it's in the mining system. Oh, one thing I would love, maybe Les Wright probably knows the answer to this, or anyone else who's competent in Python, experienced in Python. I've just imported, there we go. I imported from config the 6 cube directions inside this function, i.e. the only function where we need it. Presumably that's more Pythonic or better practice in Python to import it there rather than up here with the other imports that we kind of use across the module. However, what I'm interested in is the efficiency. Is it more efficient to do it either way? Does it really matter? If you have any thoughts on that or opinions, even if you don't know what you're talking about, anyone, do comment below. I'll be interested to hear what you think. Right, so we just need to open the mining system, I think. Possibly building, because presumably building will look in different directions. Oh yeah, I can open 2 files at once, can't I? Building and mining system. So I held the command key on my Mac, and I can open both of those. There we go. So the building system, let's look through here. 6 directions. Right, how exciting. So I can delete WP, and I can say from config, our favorite new module, import 6 cubeders, and now I can just write, instead of WP, 6 cubeders in there. Updated. Great. So that's in gap shell. Oh yes, yeah, so that's creating a shell of gaps around where we've built something so that we don't accidentally spawn walls where we don't want them to, which is quite a nice mechanism. Like, that's really important, but it's counterintuitive. Sorry, I'm kind of praising my own coding. I'm more praising the idea that, someone else must have come up with it, but it means that we can build and mine with this illusion of a really thick world. I just couldn't believe how simple it was, but how well it works. Like, the beauty in it, or the interest for me, is that we're not creating substantial visible blocks. they're just like these ghosts that are sitting on top of other blocks. But without those ghosts, none of this would live, would grow or work. I quite like that idea. Okay, so the building system, mining system, let's just look for 6 directions. No, so I think it was just those 2 places. Lovely. If we come across them, at least it's a very easy fix now. Okay, so I'm going to trust that that's okay. So it's a building system like I changed. We'll do some testing when we've done another feature. Right, 25 minutes in, we've done linear fog, we've done the config file. Refer to commenters. Okay, so let's have a little break from the code and just go and have a look. Yeah, that's a reason why I got some comments up. Llewellyn. Llewellyn. I've never seen this name before. I've heard it. I've heard Llewellyn. Is that Llewellyn or Llewellyn? Anyway, thanks for your comments. All of this is coming together now, especially with the inventory. Being able to, I know what you mean, being able to like build on the sides of blocks, being able to run across the terrain with some effects, being able to mine, having some mobs moving around with animations, and then the inventory system particularly, which Llewellyn or Llewellyn you haven't seen, Mr. Anthony, I'll call you Mr. Anthony, hasn't seen yet. It does feel like we've got like a coherent game. Oh yeah, and we can save and load terrain, so we've got like longevity for our simulation. Right, Reshmi Das, can you do a giant preloaded terrain and then continue making from that? Yes, that would be a good idea, because at the moment we're just generating a small area. But if we generated a massive terrain, then we could save that file and then just load it at the beginning. Shall I do that right now? So in main, what we do is we set up the window, the sky, the subject, and then we create our terrain object. And then underneath that, we then, which is not commented, but generate our terrain chunks. They're not really chunks, as in Minecraft, because they're flat. Mine is just like the surface area. But we don't have to do this, because when we get started, things will start generating. Actually, we haven't got generation switched on. Some of this other stuff, I presume, we could put in our config file now, instead of being kind of messily in our main file. Where is generating terrain? There it is. So let's turn that on. That's true. And this is a low number of chunks actually to create straight away. For debugging in development, we want things to load quickly. Anyway, we don't need to do that. So what we do want to do is, what's it called? Load map. Actually, that should be in our input function. Where is our input function? There we go. When we press L, load map, oh, we do need to pass in the subject and the terrain. There we go. So that will load whatever our default map name is. So let me just open that. So we need to load our, open up our save load system. So at the moment we've called that, we are, what's this, saving the map as terrain underscore map underscore one dot panda. So you have to call these different things, maybe hard code it at the moment, else you're going to write over previous maps and things. And then, yeah, we're referring to the same name. So I can't remember what state mine's in at the moment. And if you've played around with the Perlin noise, then the Perlin noise won't match up if you load old maps up and things. So be aware of that. Meaning in the future, we're also going to have to save the details of the Perlin noise, which is an easy thing to do now that we've established saving and loading. So let's just run that. I can't remember what our map state is like. If it's very large, it could take like 10 seconds, and it is taking a while, which is a good thing. because the point of doing this is to have a nice large terrain. And the bad thing might be is if we start at 0, 0, 0, our subject, our player, and the terrain is a lot higher than that, we might fall through. I didn't count how many seconds this is. Oh, we didn't fall through. Let's just press G to stop generating the terrain. Oh, I used jump there to, so I was kind of in the terrain. Ooh, got weird things going on. So something's gone wrong. Oh, this is probably from my testing my prepare code, so things don't sync up. But there we go, we've loaded a larger terrain. Right, I'm going to pause things here because I need to go and sort something out that I can hear going on in my house. And I'll see you in a moment. No, I won't because I can't move the mouse. Now I can. Okay, and I'm back. Right, obviously instantaneously for you. Okay, so what were we doing? Oh yeah, loading in a larger terrain at the beginning. So for our development, that won't be, like presently in this video, that won't be helpful because it takes a long time to load every time we want to test the code. So let's just comment that out and just say for loading in a large terrain at start, and then we'll just reinstitute our small 64 chunks, but we'll have generating terrain switched on. Lovely. Let's just go back in the code, make sure I haven't broken anything. I've forgotten exactly what I was doing before I paused, and let's just tick off anything. So refer to commenters. Oh, that's what I was doing. What's the next thing? Oh, the rate at which we're generating terrain we could play around with. So at the moment, I'm getting an okay, oh, I was going to say an okay frame rate. I mean, obviously it drops because I'm recording, but that's not great. So let's have a look at that. Maybe after some coding, I'll go back to referring to some of your comments, because you might have put in an idea in the YouTube comments that I could do during the video. Okay, so my prepared code. So it's in mesh terrain where we mesh terrain and the main module where we determine how fast things are. Oh, look at this. In my prepared code, I haven't done the config thing. Anyway, I can catch up with that. Right. Oh, yes. So the terrain generation is to do with subsets. That's what I call them, not chunks, subsets of the terrain. So we break those down so that we can infinitely procedurally generate terrain wherever the player walks, and so that things run smoothly and efficiently as I can get them to. So there's kind of a balance to be had. The greater the number of subsets, then the smaller each subset's mesh will be. So you'll gain something there. However, it'll take a little longer to load because each subset is an entity. Now, the more entities you have, you also hit the frame rate there. So 512 seems to be okay. Now the subset subwidth is in each subset or each chunk, how many individual blocks are we creating? So this would be 10 times 10, so 100 blocks each time. Obviously, the smaller you have that, at one point I had 4, so 16 blocks. That's going to, and they're being generated within a frame. So the smaller that number, the smoother things will run. So if I drop it to about 10, however, loading massive chunks of terrain each time looks a lot better and is much more satisfying. So 10 is a pretty high number actually, 100 blocks each time. Then if I go to my prepared main, so I want to change that to 5, 12 and 10, and then in my prepared main, which I can't find, again, you've probably seen this on the screen before I did. Oh, is it? Oh, it's right at the beginning. Oh, that makes sense. So I can find both of these quickly to test things. That makes sense. Oh yes, in the update function, this is like our game loop, our game engine, we we have this little, very simple mechanism where I've got a counter, a variable called count, and I'm incrementing that by 1. If we hit 2, then reset the counter. And so only when the count has hit a certain number do we generate the terrain. And then inside here, in this range, in this loop, we can create lots of terrain in one go, in one fell swoop. So I'm only doing it once here, and then the counter goes up to 2. And that's it, I think. That's all I've got to remember. So back in our proper main, let's compare things. So in the update loop, we've got a count there. Count goes up to 4 here, so we can drop that to 2. We'll drop this range to 1, which means this is a little redundant. So in fact, I could comment that out. I should have commented both of them actually. Kind of left it intact. I meant to say. There we go, and then comment that out. So generating terrain the whole time, and okay, good. And then the big job, wasn't it? The not big job, a very small job, but the big difference was the number of subsets and things. So let's try 512, and then sub width we're actually going to raise to 10, and then save all of that. Go back to main, save, and run. And let's just see if we're getting a nice balance between lots of terrain, quickly generating, but also a frame rate. Keeping in mind that I am live recording, so we've got our 64 chunks. Run over here. That's not bad. Yeah, my frame rate seems to be okay. It did drop to 12 up in the corner, but that's kind of a guide. The most important thing is how does it feel, and that feels pretty okay, especially in mind that we're recording. Oh, I like these hills over here. Now we have got some gaps in the terrain, like that we don't want, meaning we need to have a higher frequency for our Perlin noise. So the next thing I think we need to sort out is Perlin noise to improve things. One of my favourite things to do. As I said, the world aesthetic and engineering and creation, that's what I like. Okay, so let's open up the Perlin noise module, which we haven't looked at in a while. Now, inside my project folder, and presumably yours, we've got 2 modules to do with Perlin. We've got perlin.py, which is, I think, what we need to look at. But then we've got something called Perlin_module. So that's the proper Perlin module that someone else has written, someone else has coded, that has the important Perlin function on that we're using, the noise function. So we don't need to bother with that. But that's just so that people who are having trouble installing that module themselves, which you need to install as well as the Ursina module, obviously, I've got that included so that you can refer to it here rather than having to refer to that installed module that might cause you problems. So let's open up perlin.py, which is our module which we made, which we haven't looked at in ages. So what we can play around with is a number of octaves, the frequency, and the amplitude. So amplitude means like the general height of things. The frequency is like how smooth the difference between heights for individual parts or locations of the terrain is. And octaves, I think, is used in 2 different ways here. It seems to be kind of like the resolution of what you're looking at with the function that I'm using, this Perlin noise class. And usually it means like layers or tiers of these passes of Perlin noise on top of each other. We're going to use 2 such octaves. what we're going to decide, oh, I definitely need to illustrate this. JS Paint for JavaScript Paint, which I recommend to everyone. I also recommend good Wi-Fi. I should have gone and sat somewhere else. What I just want to illustrate is that we're going to add two Perlin noise, or we're going to, what's the way to say this? We're going to use the Perlin noise function twice. First, we're going to decide like a very simple terrain of very high parts and then lower parts, but the amplitude is going to be massive. So it's like thinking about like the basic foundations of the continents of the landscape, and then we're going to pass a more detailed function over that, which will add nice nice variation across, as it were, the surface of the continental foundation. Oh, and finally, we're going to add some trigonometric functions, so just like sine and cosine and things like that. I think I'll just use two sine waves just to like ripple across the landscape. Right, let's illustrate what we're doing. First, we need to sort out the theme here. Let's go into dark mode. Nice. And then let's have a background of kind of a decent blue. There we go. Right, so I need now a nice large brush. And yes, so first, maybe in black, we're going to decide like the basic shape of our terrain. And then, what colour? Like grey on top of that, or maybe a light grey. Based on that, we're then going to add another one, which will just add our wiggles and bumps like this, so that we're getting a really nice varied terrain. And then some Perlin noise, which is a different thing altogether. So let's do that with yellow. And that will just add a sine wave running across the whole thing, like that. And imagine those smushed together. I should have used like, what's it called, Desmos or something, where you can actually add together those different functions. But imagine those, the averages, something like that, taken of those three lines, and you get a really nice varied terrain. The essential thing is we're getting low resolution, smooth differences, but great amplitude added together with small amplitude change, but lots of variation. Those things combined give you a lot of variety, I find. Anyway, let's go and explore that. So, my prepared code. All we're essentially doing is adding in some different numbers, doing a little bit of copying. Oh, there's my Perlin prepared. Right, so we're using the same seed. That'd be interesting to do. Maybe we could do a random seed generation so that we get a new terrain every time. That would be cool. Right, 8, 2, 5, 6, 18 to begin with. 8, 2, 5, 6, 18. 8, 2, 5, 6, 18. So notice, first of all, we're dropping the amplitude. That should reduce the likelihood of tearing the terrain, so where we're leaving gaps. Also, you can increase the frequency. That would smooth things out as well. Now you can see that we're applying the Perlin noise function twice. So we've got essentially what I'm calling octaves, and this is the proper application of octaves as far as I understand things. So that first one is taking 8 octaves in its language, sorry, confusingly. But then the second one, we're only passing in a resolution of 1. I think that octaves really means resolution here. Anyway, let's copy that. Perlin. So everything else we can leave the same at the moment. Lovely. So also notice you could have a different seed for each of these each of these octaves, these levels. However, in my experience, you don't get that kind of like resonant cooperation between them. However, it's so much fun just exploring these. So try out, just go and explore loads of different things. And if you find anything really interesting, maybe put some screenshots up or something like that. Link in the comments. That'd be really fascinating. Okay. So presumably now, in the get height function, so this is where whenever we're placing a block, we are calling this function get height, and we pass in the location of that block, x and z, and then this function returns, well, how high do you need to make that block? And at the moment, we're just determining y, i.e. the height of the block, from that one noise function which we've set up here in the initializer. So presumably, what I want to do is, oops, yeah, have I highlighted that? Is now say y plus equals, so add on to what we've already established, noise 2, which will only have that resolution of 1, but we need a different frequency. So the frequency will be lower and the amplitude will be lower. Let's go to the repair code, see what numbers I've got. Oh, look. Oh, this makes so much more sense. Although let's rename things in the current code. So my prepared code, Perlin noise 2 is that first smooth continental foundational thing. And so we're using a frequency of 512, which is a lot higher, and an amplitude 128 instead of 18. So it's a massive. So let's go and do that first. Kind of rename things. So we'll create this first. And we'll call it Perlin noise continental. And then we'll call this P noise details. Okay. And then first we add the continental noise. And that needs to be x divided by 512, z divided by 512, and amplitude was 128, wasn't it? So that's like how high it can maximally get. Then we're adding on to this Perlin noise details, and we're just taking the frequency and the amplitude from our initializer. It might make sense to have variables for these as well later on. Okay, so let's go and run our code. See what's happening so far. So having a look at my notes. What else am I going to try and fit in? I'm just seeing that we're heading towards an hour, aren't we? And we're just doing some like housekeeping, like fog, etc. Let's have a look at our new world. Oh god, I recognise this terrain from my prepared code. We've lost our panda. Let's just press G. So it's a lot smoother. So yes, we've now got some mountains up here. Let's put terrain generation on again and see if they get even larger. But now with this like two levels, 2 octaves, you can have very high regions and then very low regions. And on each kind of region, you've got variation. So again, we're in the mountains, and we've got mountains upon mountains. which it's not really fractal, but it's approaching that. So we can look down our mountain, and now that we've got these larger terrains and things, our fog is maybe, you know, too dense. Although running down the mountain, that looks kind of cool. Oh, we've got a panda. Hello. How's it going? Still build, thank goodness. Oh yeah, so I was thinking we are heading towards an hour, so maybe I'm going to have to do itinerary in next video. No, I'll have to make a start this video. So what we can do is avoid doing all the things that I've got on my list and save some of the housekeeping to next video. Okay, so we've done Perlin. No, we haven't. We've got one more thing to do, is then add some. So after we've added in get height function, after we've added the most important things, the two Perlin noise functions, we then want to add some sine, some waves, trigonometry. So what we're saying is just add to the height so far, based on the position, z and x, apply sine to it. So basically whatever number we're putting in here, it will always follow this sine wave curve. And again, this number is just the amplitude. So the number that we get inside here, or sorry, the result of this function will be a value between -1 and 1, because it's sine. So we can take that down by a third, so 0.33, so that we're not tearing our terrain up. However, let's just copy and paste those in from our prepare code. And we'll just write ourselves a comment. So apply some surface variation for or from. No, there we go. That'll do. Apply some surface variation. I should say predictable. Predictable. Because the key thing is with procedural terrain is that we want to be able to get exactly the same terrain based on the same seed again and again and again. We don't want randomness. The last bit of randomness I've got, I think, is the colour, the tint that we're applying to each terrain block, which we need to do in a procedural way later on. So sine is not recognised, so within this function we'll do another import. So from math import sine. Let's leave off the amplitude at the moment, and we'll put in a, actually, times, we'll multiply that by s amp, multiply by s amp, and just say s amp equals 1, so having no effect at the moment. We'll just see if we get any tearing of the terrain, or if we're really lucky, it will be improved from my prepare code, and we can just leave it as this. Also note, because we're playing around with the Perlin noise, if we loaded an old map and started generating new terrain, it's going to not match up anymore. So there's a tear, there's lots of tears, but you can see what this is doing is really just rolling across the terrain and moving bits up and down, which is another nice thing. So it's nice not to just have Perlin noise, but some other noise. It's not really noise, sorry, some other functions. So yeah, it looks nice and varied, but maybe a bit too varied. And also the tears are there. So we'll say that is 0.33, so it'll make this overall number smaller, this value that we're adding to y, our height, smaller, really we should kind of combine those. So this now should, yeah, reproduce exactly what we're doing in the prepare code. Lovely. So it's kind of smooth, but there's these little variations here and there. And even though we're using a sine wave, a predictable periodic function, you can't see that regularity. It just manifests as incidental, spontaneous land formation. Let's just press G. I was slowing down a lot there. Good. So I'm happy with that. Obviously, play around with it and have the kind of landscapes that you want. So we'll dip back into this Perlin world. Off goes a panda when we start doing biomes or develop the biome system. Okay, good. Right, tick. What else have I got? Refer to commenters. Load large terrain at the start. Oh, we did that. Tick. Draw distance and vsync. We can leave that. Texture import. Yeah. Collision bug fix. That's probably BTE origin. Right. Let's just sort out the collisions. I noticed that you can walk through blocks now when they're at kind of your chest height. Let's try and reproduce that. Since doing the perpendicular building, it's being able to build on the side of cubes and underneath cubes. We might do something like this. Build a cube there, build a cube there, build a cube there, build a cube there. The collision is working fine. And then we could, whoops, we could mine those two, and we should be able to step up on those. That's fine. Delete those two, mine those two, step over those. Brilliant. Yep, panda's enjoying that as well. But what if we delete, whoops, what if we mine those two, then we walk straight through them, which is a problem. So the solution, let's see if I can do this just from memory. Open, well, we're almost at an hour, so I'll give myself an hour and a half video. You don't seem to mind the longer videos, so thank goodness, because I can't do a short video, save my life. Where is, this is the reason, because I'm just staring at things, trying to find things. I should use the pause button a lot more. What am I looking for? What's it called? Bump system. Bump system. So here we are, walking on the train itself. So this is what we're looking at. Not the colliding with vertical walls, interestingly enough, but how high we can step. We've got this little this little nested loop here. So just to remind ourselves, if the terrain dictionary, if we found a block that's within the range that we can step up on, then we want to check, you see this +1, so I +1, so then we check another one up, because we haven't got, step is not inclusive, just in case, sorry, there's a block on top of another block that we need to step onto. Let's go to the prepare code actually. I think all I need to do was reproduce this, but to go one higher. I can't quite understand. I can't understand this now. Maybe if I look at the prepare code, I bet I didn't do any comments. So there we go. Yeah, plus 2. And we go step plus 1 from -2 to step plus 1. Well, all I remember is it all making sense to me, then I'm doing it in about 5 minutes. Anyway, so, oh, wait a minute. Oh, now I get it, now I get it. So we're not doing, so we're not adding to this one. We're saying, yeah, so we can imagine if we're very, very low, no, I'm not going to try and explain it. Let's just, let's just try to implement it. I'll leave a little comment. Also check any blocks above still within stepping range. There we go. Yeah, that makes sense. Check any other blocks above. So yeah, what was happening is if we detected a gap, you remember when we mined underneath, like where our shins and feet are, but then there is a block above, and at the moment we walk straight into it. What we're doing now is just checking one more, just in case there is one at our stomach height. That's what we're checking. So this needs to be plus 2, and I'll write that in here. Stomach height. What I'm a little confused in is this range. In my prepare code, I've got plus 1 there, which I don't think is right, and then -2 here. I suppose, really, yeah, -2 makes sense. We don't want that to be affected by step height. If there's a step down, just leave it to gravity, really. But step, yeah, we want to determine by how much we can like climb up mechanically. Anyway, where were we? Stomach height plus 2, plus 2, and then it'll break there. Lovely. So it checks one above us. Yeah. So if we find a block to step on that's very low, then we just check: are there any blocks immediately above it, even if there's gaps between them, because we want to step up at that height, not the lower height. And I guess we should implement this for our mobs as well. So it tests this out. So the different thing is I've not added that extra 1 to the top end of the step height. So we're stepping up and down the terrain as normal. I can get up 1 block and get up 2 blocks. That's above my step range, so I can't get up that. That's good. Panda drops on my head. What about approaching from this side? Now it's only 2 blocks high. I should be able to step over it. Lovely. Okay, so if I mine that block, whoops, if I mine that block, yep, I'm stopped there. Mine that block, I'm stopped there. I need to build that one and that one again. And now, oh no! I do step up. What about if I do it here? Oh yeah, I am supposed to step up. Sorry, I'm not supposed to step through, so it does work. That does work, yeah, I am supposed to step on it. If I do that, I should stop. Yes. Oh, so it does work, great, okay. So everything's fine. Good. Tick that off. Collision bug fix. Good. Right, so we've gone over the hour, so now let's start our what's it called? Inventory. So let's create a new module, and this will be our inventory system. So save as. Inventory system. Good. Right. So the first element of that really is is it called the hotbar in Minecraft down the bottom? So where we can select different blocks. I don't think we'll do the whole mechanism in this video. Like I said, we've only got like 25 minutes, but just to get something up on the screen. So inventory system. We'll call it the inv for inventory. So inventory, well, it's a hotbar, isn't it? Or what I'm calling the hotbar. If it's not called the hotbar, that's just going to be embarrassing. Hotbar equals, this is just going to be an entity. Its model is going to be a quad. So that's the simplest, like 2D sheet of paper, as it were. But the parent of our quad, usually that would be the scene. So that's the 3D world. But we don't want it to be like inside our world. This is just like on the screen. So it's part of our camera's UI, so user interface. There we go. Now this module hasn't recognized entity or camera. So what we do want to do is from Ursina import everything. Now we're going to import everything so that we can use our own textures if we want to. Let's just see what we've got so far. So in our main module, of course, we need to say from inventory hasn't recognized it. System import everything. Save. I don't see him. Where's our inventory? Did I save this? I did save this. Parent equals camera UI. In main, import everything from our inventory system. And you're still not appearing. Let's see if it's related to a bug or an incidental thing that I wanted to show you anyway. If I put this after we've actually generated our, whoops, oh I didn't, I didn't copy it. After we instantiate our Ursina window, does that not work? Yes, it does. Interesting. Oh, it might be because I didn't set a texture, so it couldn't load the texture. So the default color and texture is like this white cube that we get. So notice how it's flushly fit the screen. Now my screen, my resolution is longer wide than it is high, so the width and the height are different, and so by default it matches the height. So that will be 1. So at the moment the scale is 1 of my guy. Now what we need to do, my guy, my hotbar. So we want to shrink the hotbar down to the bottom of the screen, ready to have like the 9 boxes, don't we, that we want, and we need to change the color and things. Now, what I noticed was if we want our modules to import everything from Ursina and load textures and appear things properly, it's mainly an issue with textures. One second, I've got a phone call. Yes, so what we're just saying, yes, if you're having trouble with Ursina loading textures and things, I certainly had this trouble. What you've got to do is, firstly, in the module where you're trying to, so it might be like in your mob module or something like that, where you're, well, the first thing you need to do is import everything, so asterisks from the Ursina module. So then you have access to the texture loading and things like that, and model loading. And then in your main module, before you import your module, you must have the Ursina app instantiated. So that's what I found through trial and error. So after we've imported Ursina in our main module, let's run the app up there. So, and I'll leave a little note. So instantiate Ursina here so that textures can be loaded without issue in other modules. Smiley face. Good. Now I can kind of bring these other imports together. Okay, so we need to squash him down. Hotbar, your scale, so we only need to worry about the scale on the y-axis. It doesn't have a z-axis because it's only a 2D flat thing. Equals 0. What about like a tenth of the whole screen? Let's look at this. That's about right, isn't it? And now we need to move him down. In fact, it looks a bit long. So we'll try 0.8. No, that's 0.08. There we go. And now we need to move it down. So in my prepared code, I've done it via the origin. But surely it's just got an X and a Y. So Y equals, now we're dealing not in 3D space anymore, we're dealing with user interface space. And you can see my body language, it's like, oh God, it doesn't make sense to me or anyone else. Let's just go on to the, oh God, look at that gorgeous diagram. Let's just go on to Ursina, the Ursina website. And I'm sure they've got, Peter Amland in his infinite wisdom has got a nice guide, probably in the documentation. Ursina's coordinate system. So that's 3. UI, here we go. Lovely. So this is where we are. Want a different UI coordinate system? Ooh, yes I do. No problem. Camera UI is an entity as well, so you can move and scale it as you see fit. Well, we should experiment with that in the future. Okay, so here's our screen. 0, 0 is the middle. Top right is 0.5, 0.5. I already don't understand. Wait a minute. The window's top right. Oh no, so this point is 0.5, 0.5. 0.5 times the window aspect ratio 0. Oh, okay. So everything, yeah, is based on a square. That makes sense. So everything can be evenly placed out. However, if you want to take into consideration the fact that the width is different to the height, then all you have to do is multiply the x component, so the first number, by the Windows aspect ratio to get it all the way over. That's great. And so minus goes left and down, positive numbers up and to the right. Seems so simple. Right, so the hotbar Y equals, so we can put in a tuple, no, we're only dealing with one number, aren't we? So that wants to be, so we're going down, it needs to be minus, let's try 0.5, because that would be down at the bottom. Now, will that be halfway off or not? Let's see. Whoops, I don't know what I just pressed. Back to main, let's run the code. Now, you could add a texture to your UI elements, your inventories and hotbars and things, which is a good idea. I'm going to try and do things through the code. Oh, good. That kind of makes sense. So it's halfway hanging off the screen, which is what we kind of expected. So that puts us onto the bottom of the screen, and then we want to minus half the width of our, sorry, the height of our object itself. So minus hotbar. Or can we just, no, let's just do what makes sense. Oh, no, it wants to be plus because we're going up. Plus hotbar scale on the y-axis. Oh, that needs to be divided by 2 or times 0.5. Does that make sense? Does that work? Welcome to the world of user interface coordinates. Oh my god, that's worked. Okay. That's weird. Usually things, work off camera and makes complete sense. A bit like that collision thing I was doing a little while ago. And then when I come to record myself in front of people, then nothing makes sense anymore. Now it's working the other way around. Maybe I've actually learned something in the preparation. Okay, so we've got like a hotbar. I think it's a little bit too wide. So let's sort that out. So instead of, oh, it's still set at 1, isn't it? So we can say hotbar scale x equals, 0.8 to match that other 8, although they're kind of different. Right, now, so let's just record some comments. So we're set the size and position, and now we want to set the color. So appearance, I'll call that appearance. So hotbar dot color equals, so Minecraft goes for like grey, like Windows 95 kind of aesthetic, isn't it? So color dot dark grey. Now we can access all of these color things because we've imported everything from Ursina. So these are built-in like keywords and things, defaults from Ursina. Okay, so we've got that dark grey thing there. Good. Next step will be to either be able to like pause the game and move our mouse around for the proper inventory, not just a hotbar, but also kind of have like grids on our hotbar on the at the bottom with different textured materials, different textured, cubes ready to go. Good. Little panda. Okay. So yeah, more satisfying I think will be the pausing. So let's write a function here called inventory inv underscore input, and so we'll call this from the main module. It's got its own input function, so whenever that function runs, we'll run this function as well. We need to pass in a key. We'll probably need the subject and the mouse. The mouse. We haven't really dealt with the mouse before, so this will be useful in many of your Ursina projects, I'm sure. And what we want to say is, well, if key equals, we'll go for E, or is I the inventory in Minecraft? Let's go for E. That's what I've done in my prepare code. If it's E and we'll say the subject is enabled, then we want to say the subject, well, we'll disable the subject and mouse locked. Is it called locked? I think it is. Locked equals, I was get this the wrong way around. It should be easy. So we're disabling the subject. So we're paused. So locked equals false. And we'll say else if key equals E and subject and not subject enabled, then subject enable, so re-enable the subject, and mouse locked equals true. Okay. Now if I go to main, and remember we've imported everything from the inventory system, so we can access that input function. There we go. So we're in the main module and we've got this input function. So similar thing to what we've done with the terrain. Underneath here, we'll call this inventory access toggling. We'll say inv input, and we just need to pass in what key's being pressed or detected, the subject, reference to the subject, and reference to the mouse. Whoops. And this mouse object has already been sorted behind the scenes by the first person controller prefab built in to Ursina. Okay, let's just go and see if that's worked. So now if we press E, it should like freeze the movement of the player, so that's disabling the subject. And if we press it again, we'll re-enable them. So at the moment, walk around as normal, building, mining. If I press E, you can see the mouse has appeared and I can no longer move forward or backwards. Oh, I can press Shift and W, I can still get the change the field of view. Quite nice. And if I was looking at a block, I could build and mine by pressing that. So I need to disable all of that as well at a future point. But yeah, you can now see your mouse again, which is very nice. If you want to exit, you can exit now. If I press E again, mouse disappears, it's locked again, in other words, and subject is enabled again, so we can go around. So in other words, it's a nice way to pause your game very quickly. Notice though, although the subject's paused, disabled, our mobs are still enabled, so the world is still kind of living around you. Now this means we can also pop up another, like a full inventory here, and start dragging objects around to a hotbar and things like that. So we've got the basics established there. Good, so that's worked. Okay, so there's that code again. I should write a little comment pause and unpause ready for inventory / crafting and things. I don't really know anything about Minecraft crafting. All I do is the handful of times I've played it is walk across the landscapes and look at caves and things. So I'll have to play some Minecraft as homework to work out what I'm doing when we're doing crafting. Okay, what is it? It's like 25 minutes past. Right, I should probably see if there's one small job that I could do. Oh, I've done the texture import bug fix where we put the app we instantiated Ursina up here before we imported the other modules. Oh, what's that? Oh, module spec when I accidentally clicked on something. So we sorted that out. Collision bug fix. Yeah. Draw distance. Refer to commenters. Oh yeah, we could have a look at some to finish off. Say thank you for watching the videos. Let's look at some of your comments. Yeah, we did the preloaded terrain. I wouldn't say it's giant. It's like larger, but I'll have to think about developing to go to larger terrains and things. Well done, Creative Cast. What was that? Video 12. You were first. I should do some kind of prize, like you get to design some feature of the game or something if you're first or something. I don't know. Dylan Barnes, great series. Going to go through all of the video. I want to point out that in video 4, you don't need to set the BTE. Oh, that does remind me of something. Yeah, in the last video, video 12, we replaced the BTE, which was a standard default cube, with our own object model, so it syncs up with the terrain. But one thing that I noticed when I'm adding blocks to the underside of other blocks, let's show you this. Our BTE's like yellow highlighted effect, what's it called? Z fights, or like tears the texture, which is not up to our standard. So if I build some, again, marvel at my building ability. One day you could be as good as that. So then, oh, actually, I could go look at it. Oh, whoops. Oh, there you go. So you see, it's the highlighter is like fighting with the other texture. That means the two textures are at exactly the same height, same position, which means the computer's like, which one do I show? Tries to show them both, and it looks horrible. So what's actually happening is the BTE is a see-through cube that's at the Panda. That's not really. This is classic Panda behavior. It's just a see-through, a transparent cube. And so what's happening is my model is kind of positioned from the bottom. Its origin is not quite right, or something like that. So we need to move the origin of the BTE up or down. Can't remember. One of those, so that the highlight is positioned more appropriately. Where are we? So we need to go to the mining, the mining system, which I've got open already. Right, so we're in the mining system, which we haven't looked at much this video, but there's where we create the build tool entity, and its scale is set slightly bigger than our actual block. So something I did in my prepare code was to make it quite a lot bigger. Something like that, maybe 2. So it looks like kind of like a jelly that's around the cube, which I kind of like. And then what we need to do is then say the bte's.origin on the y-axis is going to be, so it's like its position relative to its visual body. So the origin, If I go up, that'll move it down. Is that right? So if I say plus equals, I don't know. Oh, it's going to be 0.5 anyway, isn't it? Is it? No, I don't know. Let's just try that. So it's kind of like a skin or a sleeve around the cube, which is now thicker. My chihuahua is saying it needs to be the end of the video now. Okay, so now we've slid the origin we've gone in the right direction, that's good, but way too far down. That's not great, is it? Mining system. So we only want to go down maybe by like 2, something like that. Again, it would probably be helpful for me to just look at my prepare code for these numbers. So my scale was quite large, 1.1 and 0.05. Oh, so like, yeah, 1/10 of that, okay. So 1.1 and then 0.05, that's right, isn't it? Yeah, I like that. The way it's larger than the block itself, but fits snugly around. So now, if we build up and create some kind of overhang, yes, underneath the cube, it's snugly fit around, covering every side. Lovely. Right, from Panda and me, thank you very much and goodbye. I hope you have a lovely rest of your day. And I'll see you in the next video. Any questions or suggestions, do put them either in the comments, or if you visit the repository where you can find all the code and all the assets, you can go to the Issues tab and request there if you want as well. Thank you very much and goodbye.